Let's check your work from part 3. Number 1, we know that B is true, but P is unknown. It doesn't matter though, because anytime the statement on the right-hand side of a horseshoe is true, the horseshoe is true. It doesn't matter what the truth value is of the statement on the left side of the horseshoe when the right side is true. Number 2, we know that Z is false, but we don't know what Q is. But again, it doesn't matter what Q is, because anytime the statement on the left side of a horseshoe is false, the horseshoe itself is true. It doesn't matter what the truth value is of the statement on the right side. All right, number 3, we don't know what Q is, but that's okay, because we know that B is true, and anytime the statement on the right side of a horseshoe is true, the horseshoe is true. Over here, we know that A is true and Y is false, and that tells us that this horseshoe here is false. So now that we look at the truth value under this horseshoe, truth value under this horseshoe, and that lets us know that the main operator here is false. Number 4, we don't know what Q is, so we don't yet know what the horseshoe is. We know that A is true, but we don't know what P is, but it only requires one of the two statements in a wedge for the wedge to be true. So we know this wedge is true, and because now this wedge is true, the statement on the right side of the horseshoe is true, and anytime that's the case, the horseshoe is true. Now we come over here, and again, we don't know what Q is, but we do know that B is true, and that's enough to tell us that that horseshoe is true, and we know that Y is false. So if the right side of the horseshoe is false and the left side of the horseshoe is true, that tells us that horseshoe is false. And now we look at our two operators on each side of this triple bar. We've got true over here on the left-hand side and false over here on the right-hand side. They don't match. And anytime the truth values on each side of a triple bar don't match, the triple bar is false.